So I will try and make this as easy as possible for the people who don't know Scala. There's nothing in here that requires any particularly deep knowledge of Scala syntax or the type system. But maybe the second half of the talk where I demonstrate the library is possibly a little bit less relevant to you. But welcome to everyone, whether you're a Scala user or not. I'm going to be talking about a library I've been working on for the last few months called Contextual, which does something very dear to my heart, which is to make it harder for people to represent types that shouldn't exist. That is my goal. And the talk came about, or the library, should I say, came about as a result of another talk I'd been giving. I gave a talk called Interpolating Strings Like a Boss. And the way I structured that talk was in 4 sections, starting at value level, moving up to type level, to macro level, and then boss level. And unfortunately, when I was giving the talk, I lost everybody apart from Miles Sabin by the end of the value level section, the first quarter. And then Miles was lost somewhere in the third of the 4 sections. I was lost somewhere in the middle of the 4th section, but I carried on anyway and it didn't matter. So I thought, rather than try to describe these rather complicated concepts, you'll see what I'm talking about later, but rather than try and describe these complicated concepts in a 45-minute or even 1 hour talk, it would be easier for me to just build a library around them. And is that better? We're still getting a little bit of feedback, aren't we? Let's try this. Can you all hear me just as well as before? Fine, good. I'll do it without. Rather than try and explain things to people through a relatively short talk, I would just build a library so that I could explain the usage rather than the actual reasons why it works. And that's what became Contextual. And broadly speaking, the purpose of Contextual is to make it easy for you to check interpolated strings at compile time. So I guess everybody who's used Scala is familiar with the S interpolator. We can substitute a value such as my name, which is just there, into a string there. And this returns hello John. Nothing particularly exciting at all. And actually, these are really very boring as interpolators go. They do nothing that I would consider exciting. You can embed any type you like into one of these interpolators. It just calls toString on it. And the return type is always a string. It's nothing particularly interesting. If you like stringly type stuff, I'm happy for you, but we generally prefer to do things in a more structured way. And point 3 there, which maybe seems really obvious because this is a string, but the literal parts of an interpolated string, so not the substitutions, the bits that are known at compile time, they can contain anything with an S interpolator. I mean, it's a string, you can put anything into it, but the relevance to that point will maybe become more pertinent later when you consider that maybe that shouldn't be the case. So what actually happens when you write an interpolated string like this one? Well, the Scala compiler consists of several phases, where it starts with parsing, then it goes to naming, then typer, and then there's a typer is the big phase that does most of the difficult work, and then there's another 20-odd phases after that. But most interesting stuff in Scala happens in typer. Most of the compile failures will typically be during attempting to type check your code. However, this gets desugared in parsing prior to the typer. So when you write that, stick an S and you write some string, then some substitution, that gets desugared into the text below. And as far as the typer is concerned, as far as most of the mental models you will have about how Scala works is concerned, when you write that, the compiler sees the second line there. So the desugaring is it's kind of simple. This prefix here becomes a method invocation on a newly constructed string context object. The string context object is given all the fixed literal parts of the interpolated string as repeated parameters. And then the expressions that get substituted, in here it's just a single identifier, name, but it could be some more complicated expression. That becomes a parameter or multiple parameters to that method. Is that all okay?
How does it know where to put it?
Say again?
How does it know where to put name? How does it know to put it in between the two? Is it just prefix and suffix? Or?
So the number of parameters here will be one more than the number of parameters here. So they alternate. So you go 1, 2, 3, and then there might be more. So they will intersperse. So in this simple example where there's only one parameter there, but it goes between them, yeah. So can anyone tell me what this does? What if you type this into the REPL, what result do you get? Just shout it out if you know. Louder? No. No.
True.
Yes. True. Why do you get true? Well, has anyone got it? Here is the desugaring. Because I can barely see this. Equals here becomes the method name. It constructs a new string context. This is a case class. So it has its own equals method defined, which means that you construct another one here. It's not referential equality, it is structural equality. And this one happens to be the same as this one here. So it's true. Well done, Runa. So the point I want to illustrate here is that the desugaring is dumb. It doesn't know any of the details. It doesn't know that equals is in some ways a special method. I mean, in many ways, equals is not a special method. But it happens before any of the complicated type machinery of Scala kicks in. And as far as the typer is concerned, it sees this second line here. But what that means is, all we need to do is make that desugared version of the code compile. So anything that can be written like that second line there, in that form, and if we can get something like that to compile, then we will for free get this interpolator. So that is the syntax out of the way. So given that we have now the flexibility of working with something that is basically just a method invocation on an object that is newly constructed but has a very predictable structure. It will always be a string context. It will always have some number of parameters, and they will always be strings, all of them. So given that we know that, it is me. Given that we know that, we can do some. There's a few little tricks we can do. Now, the string context does not have a method called s, but we were calling a couple of slides ago. We were calling this s on string context. So how does that work? Well, the answer is by means of an extension method. So how many people here are not familiar with extension methods or decorators? So just to give a very brief description of how they work, if you try and call a method name on a type that does not have that method defined, the compiler will go and look through implicit search to see if there is an implicit which converts it to a type that does have that method. So this allows us to extend any existing type or some constrained subset of types to something which has that method. So we can provide an extension method to a string context and give us that s method or some other method with any name we choose. And we do that with an implicit class. I'll show you on the next slide. We don't have to return a string, we can return anything. We can return whatever type we would like for our particular interpolator. We can change the number and type of parameters. Now, in most cases, I think you'd probably want to have repeated arguments. You want, like most sort of things you would choose to substitute into an interpolator string, you could have an arbitrary number of them. But there's nothing to say you can't define the method with exactly one parameter or exactly 3 parameters, or overload it to have a one parameter version and a 3 parameter version. And the types of those parameters can vary. All you're trying to do is make that desugared version compile. So that is an option. I'm not going to explore it very much, but you can do that. And of course, the interesting one at the bottom, the powerful one, is to implement that with a macro. And that is what I've done in order to save me the trouble of explaining what's in that macro. So Contextual is a macro. It gives you the ability to extend that macro and provide a lot of additional functionality, but it does that in a way that does not require you to understand any of the complexity around macros. It completely hides that. So when you're implementing an interpolator, that is done without needing to be aware that it's a macro, without needing to be aware that it lifts your code that is arbitrary code, but anything you can write that operates on ordinary strings, it lifts that to the compile time. You don't really need to be aware of the more complex details. And I think that is a good thing. Working with macros gives you a huge amount of power. Contextual gives you one particular usage of that, which is highly constrained and a lot safer than having all of the power of macros at your hands. So let's, as a very quick example, let's say we wanted to re-implement that S interpolator. I'm going to call it sub. So we want code like this here to compile. So, like I said, we have an extension method which is def sub. It's an extension method because it is appending it or decorating this string context type here. And it'll always be a string context that you decorate, because that's always the type you get. The return type is string. It has a number of substitutions, and they are typed as any, because you can put any type in there, and toString will be called on all of them. Now, the context, this is the string context that we have, has a parts method that gives us access to the string literals that are the fixed, the known parts of the string, the static parts that are known at compile time. So I'll make the distinction, and it's kind of fundamental, and it's sometimes difficult to get your head around, but at compile time there are the fixed literal parts, and then there are the variable unknown parts. And I'll often refer to the unknown parts as holes, because at compile time they're nothing more than holes, and the fixed parts there. And we're going to call the intersperse method on that sequence and intersperse it with these strings from the substitutions, and we're going to join them all together. Does anyone see any problem with that? You all trust me too much. Intersperse does not exist as a method in the Scala standard library, but for the purpose of this demonstration, I will pretend it does. Writing, it's actually there's an interesting point here that it's kind of inconvenient to write in a neat functional way, or at least on a single line, this interspersing function when the number of elements in the two things you're interspersing differs by 1, which they always do. Number of parts is always 1 greater than the number of substitutions. Anyway, that's my own slight annoyance. So to recap, or to maybe reveal or detail what Contextual does, it gives you the possibility of writing arbitrary code which operates on the literal parts of your interpolated string. It gives you the ability to specify for each hole in your interpolation, for each hole you can give it a context. Now the context is conditional on the type of DSL you might be embedding. and you would create your own set of contexts, which you will then be able to apply to the wholes. Now, the context will determine how that particular type is interpreted, and you can restrict which types can be embedded in which wholes. Like some places you might want, I should say, into which context. So maybe you have certain places in your DSL, your parsed DSL, where you want to embed something, numbers, so ints are good, doubles are good, but not strings. Other places you might want only to embed some sort of ID type or some structured type, who knows. And depending on the type you're embedding in that position in the interpolated string, it may be interpreted in a different way. So strings may be interpreted in a way whereby they're wrapped in quotes, because we need to make them safe, or they might be escaped. Whereas a number, you can embed as a bare number. So embedding, for example, a type into some JSON, the int, you just call toString on it, that's fine. But a string you would need to wrap in quotes. Does that kind of make sense without me really explaining how Contextual does it? But sort of given the problem domain, these are the sorts of things we need to do. And one additional thing which I think is kind of important, and I was very keen not to leave it off, is to be able to extend these embeddable types later. If you're writing a contextual library to parse JSON, sure, you'll provide embeddings for int, strings, the number types, the booleans, and so on. But you haven't anticipated all of the different types your users will want to use as well. So we need to provide an extension point. That's done with type classes, maybe obviously, but that was the natural way for me to allow you to provide your own embeddings. And these are just examples here. So some of these points above have some context. Pun unintentional, actually. So let's look at a few of these. I'm going to talk about. These are all things you might want to embed in. You might want to write your own interpolator for. This is certainly not by any means an exhaustive list. Some of these are small DSLs, times and dates. Some of them are like more complicated things like CSS or HTML. So if you had a time and date here, and I am right on schedule, I think. Thank you. This is my test to see if I'm ahead or behind schedule. I'm kind of implying that I had a schedule, aren't I? I took a stab at what time I'd get to this slide. Anyway, maybe you want to be able to embed dates and times. And what we want this to do is fail when we enter this in a format that is not valid. If you gave 65 minutes there instead of a number less than 60, then we would want this to be a compile error, not an error that is discovered at runtime when something tries to parse this. So that's like a very tiny. You wouldn't even call it a DSL. It's a tiny pattern that must match. Slightly larger, you'd have things like URLs, files, class path. Now with the class path, you could reasonably check whether this thing exists on the class path before compiling it. So in your interpolator, you could write the code which says, well, the user is trying to access this thing. This will only succeed if it's on the class path. I mean, give or take the fact you can reconfigure your class path when you actually come to run this. But we could make a reasonable guess, and we could be safe rather than sorry, and fail in the case where something is not on the class path. Likewise, if the file, like assuming your code is only ever going to be running your own machine, you could check whether that file exists. These are possibilities rather than necessarily the right way to do it, but you have the option of writing these. You could throw in some Haskell. Here's a Fibonacci function. I was working with Tony the other night to try and get something like this compiling, and it's definitely possible that you could compile this to an object representing the Haskell, and you could run it, and you could have this fail if the Haskell syntax was not valid. It needs a bit more work, but it's a possibility. Here's a couple of regular expressions. This one is not right. There's no closing parenthesis. So we would want the compiler to fail at this. And additionally, it could fail with a little cursor which points to the position within that string where it thinks the failure has happened, or where it wants to indicate to the user to pay some attention. In a bigger interpolated string on multiple lines, that could be very useful. How about this, user-facing messages? One thing you could do is say, well, this is for users, but we want things to be spelt correctly, and there's an error just there. The compiler could check a dictionary. There's nothing to stop because you're writing arbitrary code. You could load a file that contains a list of words, check that each one is in that dictionary, and fail if someone misspells something. This is actually genuinely useful. You might have to think about ways you would work around situations where you're using a word which isn't in the dictionary, but maybe you just edit the dictionary. But we can do this. JSON I've talked about a little bit. Here's another failure. We'd want to point at this character here as this closing square bracket as being invalid. But the top one will compile fine as long as foo is the right type or a suitable type. Here's a more involved example. I've got actually several different interpolators here, ID, size. There's some CSS there, and I'm going to embed that in some HTML. Now, this, so I'll look at the conditions under which these might fail. These are the sort of the interesting cases. I mean, if these were all strings, it'd be boring and they'd all work fine. But we want better checking. So let's say this ID would fail if it contains spaces or characters which aren't valid for an ID. So there's opportunities to be safer there. This size, this is a CSS size. Ems are a valid unit. 1.5 is a valid number, so this is a valid size for CSS. And we can embed that in this CSS interpolator here. The selector, I don't know how many of you here work with CSS at some point in your career. You can admit it, it's okay, we've all... Who's never had the misfortune to... One person. Well done, I'll teach you some later. But we could have some more type-safe CSS here, which you would all love much more than having to work with the untyped CSS, because it will allow you to use an identity here, and when you use an identity, it prefixes it with a hash, so it will know how to substitute that in that position. The size is a valid parameter to this property. It can check that the property is a valid CSS property, and it will of course check that the syntax with these braces is correct. And then we can substitute that into HTML. We could additionally have the HTML parsed, checked for correctness. We could have the context here, context inside the head tag as a suitable place for putting a style sheet. Whereas if you were to put those styles elsewhere, we could have that as a compile failure. You can go as far as you want, really, in how you check this. Now, the reason this came about, this particular example, this is something I had in my monolithic Rapture library just over a year ago. I was working on a website, writing CSS and HTML. It was very unpleasant. And it was late at night as well. And I was trying to get the CSS to work. And at some point, I accidentally deleted a closing brace for a set of properties in the CSS style sheet. And there was no safety net to say you've made this mistake. There was every possibility of checking that CSS before deploying, but nothing was doing the checking. And what I'm about to show you is what caused me to go and write this interpolator. So what might happen if, let's say around the middle of the CSS, a closing brace is omitted? I'll tell you, you might lose half of the styles for your CSS. And certain images might appear larger than they should. This is John. This is Miles Sabin's dog. This is John's freshly licked head. This is what I saw. I took a photo, and there's some text in the background here. It's an abomination. This all happened because one brace got removed accidentally, and there was no safety net to save me. So I went and implemented in Rapture, not using Contextual back then. I was doing this manually, so to speak, writing the macro directly, but allowing me to have my CSS checked, to have all my IDs verified that I'm using the same ID within HTML as I'm using within CSS, checking the spelling, cross-referencing. And back then I didn't really anticipate this being generalized to Contextual, but now it's a possibility. And maybe if I have time, this lifetime, I will work on a CSS interpolator again. So that's kind of the intro. I'm going to give you a more specific example, which is XML, and right on cue, someone is leaving.
Right, bathroom.
Okay, XML is enough to make anyone want to go. So we're going to. I'm going to talk through. This is my sort of example of a library built upon Contextual. And Scala is sort of underserved by XML libraries, at least in comparison to JSON libraries. So I thought I would do another implementation of XML, particularly as XML literals are going away as soon as Martin agrees there is a suitable replacement. So maybe that will be Xylophone, this library I'm working on. Maybe not. But Xylophone is an implementation based on Contextual. A lot of this I've sort of gone over already, but very quickly, this sort of thing is fine. We can substitute a string inside XML here. This will be checked for validity, so that one is all good. Likewise here, well, maybe not likewise because this is not good. We're trying to embed a type exception into some XML, but what is the correct interpretation for an exception when substituting into XML? Well, that's not a type we want to include there. And it's not something that we would be satisfied as functional programmers to simply call toString on and assume that the value is appropriate. So we don't do that. We don't allow that to compile. The parsing must work, and in order to get this to work, I wrote a parser for XML. I mean, it's probably got a few bugs, but it's written in a very clean way. You can look at the source code on GitHub under propensive/xylophone. But there's a couple of hundred lines, functionally implemented parser, which will check that things like this will all work fine, whereas stuff like this will not. This bar doesn't have a closing tag, so that's compile failure. This baz, I think, is kind of hard for me to see what I've put here on the slide, but this baz, sorry, no quotes. This expression here, the expression looks fine. 1 is less than 2. It's even true. But this looks like the opening of a tag. So this is not valid, so we don't want to allow that. And these are the kinds of things you might accidentally substitute into or put into your code. Before a library like this, or before Contextual, you would discover this at runtime, which is the wrong time to be discovering these sorts of things, especially if it's on a rarely used path that's not tested. Here is another example. Say we wanted to substitute this content value into the XML here. Now, it turns out that if you did plain old string substitution, this would actually be something that's valid code. But in the general case, we don't know that this arbitrary context string here just happens to contain the suitable text to close that tag. So we have to forbid this. And conversely, if we were to substitute something like this in a position here, we don't want it. We don't want to include these characters here because they haven't been escaped. So we would actually a closing angle bracket would work, but we would feel much more comfortable if we escaped it using this mechanism here. So Contextual allows you to do that escaping safely. And this is a worthwhile point to make, is that this is kind of important for security as well. If you're substituting strings into strings, it's nicer if you don't have to think about escaping. Injection attacks, I think I saw on some security training I did, were the most common of security breaches. They're very easy, especially for beginners to create the opportunities for injection attacks. And this makes it virtually impossible to, assuming the library is doing what it's claiming to do, this makes it virtually impossible. So one last slide on the XML. The context is important. The context where you make the substitution is important. So we've got my name in a string there. These two, the second and third lines here, they look very similar, except the name is in quotes in the second one and not in quotes in the first. But we can unambiguously interpret those in two different ways. In the first example, we know that in order for this to be valid XML, we need to wrap that name in quotes. In the second example, the context is different. The context is something representing being inside a string, inside the quotes. So we know that we should certainly not put quotes around that substitution. The third one is fine, we're just putting the name in XML body. And the third one we forbid because in the general case we can't, although it happens to work in that example, it would be valid in that example, in the general case we can't do that. And that is because the context here at this substitution point is not suitable for anything to be substituted there. Is that all? Yeah, Chris?
So in the second and third examples, is escaping handled contextually?
So in the...
So it's like escaping a double quote.
So I've got three answers for this. In the current source code that is in Git, it doesn't escape at all. But there's every opportunity, I just didn't do it because I was lazy. In I've forgotten what my other two answers were. What was the question again? Is escaping handled? So in the
Can it be handled?
yes, it can be handled contextually, and absolutely is. In version 1.0.1 of Contextual, which is the current release version, it is handled in the type class that you define as a downstream user of the XML library. And I'm not happy about that, because you could always get the escaping wrong in an extension type class which you write. So in Contextual 2.0, that escaping will be handled inside the interpolator itself. So I've got some changes which are going to be made over the course of probably the next couple of weeks, which will make things tighten that particular hole.
In the last example, is there anything that would stop you from knowing that you're in the context of an element name? Are you using that name actually?
Anything that would stop you from
just adding a new context of element name? Like you can string, like attribute values, then inside a string.
so if name wasn't a string, if name was some sort of tag, I mean, okay, if you really wanted to, you could create a name or thing, a value which represents a self-closing tag, and you could probably write the code to allow you to substitute only a self-closing tag in that position. But this might just be an opening tag which has to match with a closing tag. In the general case, you could even have allow it in an opening tag and later on in a closing tag. And if you assume those two expressions are pure and always return the same thing, because yeah, you're making assumptions, and it was just easier to say no, we're not going to permit this. But it's worthwhile. I mean, what you might want to do is not have these angle brackets here and have name represent a tag of some sort. Some substitution of XML, and that is in fact allowed. You can substitute XML within XML, provided it's in the body here. You obviously can't put XML into an XML attribute. Okay. Right. What is next? So the ability to add additional types. Say we have a record type. I have no idea what record really is, but we want to be able to embed it in XML. We can, when we're defining record, now record is not something that is part of Contextual, it's not part of Xylophone. It's something we as a user of those libraries have defined ourselves. So in its companion object, maybe we want to define how you embed a record. And the way we do it is using the syntax here, which makes it very easy for you to create an implicit of a type that is incredibly complicated, but you don't need to see it. Now, as long as Scala continues to support implicit vals which don't have an explicit type annotation, this will be nice. But I think that feature is maybe going away in Scala 2.13, in which case you will need to write or somehow infer a horrible type which goes there, which represents this thing here, which is an intersection of singleton types, which is part of the complexity of Contextual, but it's the complexity that is generally hidden. So I'm waiting to see what happens with Scala 2.13. I'm hoping we can continue to write these in this quite nice syntax. What this is saying is, if you're trying to substitute a record, if you're in body position, this is the XML body, so anywhere outside of a tag, then we will just use the name of that record. We substitute that as a string in that position. Whereas if we're on an attribute, then we're going to substitute that. We're going to substitute the ID, so it's a bit like that as a reference if it's an attribute position. So the way you do the way Contextual interprets a particular type is dependent both on the type and on the context you're in. What I'm going to do towards the end of this, well, just in a couple of slides actually, is talk you through how you would build the few steps you need to go through to build your own interpolator. So maybe this will make more sense when you see how it's done. You can also do a type class based embedding. You could embed anything that can be shown. So anything which has a corresponding show type class, we can write this here, and I've dealt with another. I've actually shown you how you can write it with slightly different syntax in each case, just to be different, even though these are all doing exactly the same thing. So the 7 steps to writing your own interpolator. Now, I'm going to talk you through an interpolator for URLs. So this is a reasonably simple example, but it does allow for substitutions. So what I'd like you all to do is think of some sort of DSL you work with on a day-to-day basis that at the moment you have to parse, or that you have a type that potentially involves results in runtime failures, and think about how that might be implemented in Contextual. And if you think about it in terms, well, it might be that the type you have, or the use case you have, has no substitutions. Those are perfectly valid cases, and I think maybe there are more of those than the more complicated DSLs which allow substitution of Scala types. But think about whatever you feel comfortable with. I want you to consider that everything is a lot more complicated if you allow substitutions. So if things get a bit hairy, focus on the simple case, and hopefully you'll still see there is some usefulness in the library. So we're going to write an interpolator that will interpolate, in fact, something like this. An HTTP URL. We want it to fail if we get the scheme wrong, or if we substitute page variable in the wrong place. So 7 steps: create the interpolator, bind it to a prefix. This is going to be the URL prefix in this case. check the contents. Now that could be parsing it, it could be running a regular expression over it. It could be checking that, I mean, it could potentially be for a non-variable URL, it could be going to that page and checking that it doesn't return a 404 and failing compilation if it does. But we're not going to do that. We're just going to check it's the right form. Having compiles dependent on the internet is a bad thing. We want to define the context, the different contexts where you might substitute things into this URL. And then we want to contextualize. This is where the name of the library comes from. We want to contextualize those holes, those substitutions. Point 6, everything I've talked about so far has really talked about the compile time. But once we've passed compile time, we actually need to evaluate this thing in some way. So we need to define how that's done. That is a requirement as well. And if we're going to embed types, then we need to specify type classes like you saw on the previous slide, type classes for embedding those types. So you've kind of already seen that. So step 1, really easy. We create an interpolator. It's an object. It extends from interpolator. That's it for now, but these ellipses will be expanded. To bind that to a prefix, this is equivalent to the extension method I showed you very early on. All I would say is copy this code, and the bits you need to change are, I mean, give it a name, whatever name you like, it doesn't matter, but change this identifier here, that is your prefix, and change the name of the interpolator you're going to bind to that. This is the macro. This is where the macro gets expanded, but it's going to be basically the same all the time. We want to check the contents of our URL, and to do that we implement the contextualize method. That takes one parameter, a static interpolation. The static interpolation is contextual's representation of everything we know about that string, that interpolated string, at compile time. It is a subset of the information we know at runtime. But at compile time we have access to this, and in particular we have access to a list of strings which are the literals, the literal parts that surround the holes. And for now we're going to return nil, but don't worry about why. So I've not really included the code here because I don't really care what you do to check this interpolated string. You can put arbitrary code in here and you have access to this method. So this is where you would write whatever arbitrary code you want to run at compile time. Okay?
What's the return type?
The return type is actually list of context, but I haven't talked to you about the context yet, so we're just returning nil. So I've deliberately left that off. That will appear shortly. Oh, I did actually provide a simple example. Yeah, so if something does go wrong, like if you find an error, you want to tell the user. So I've written what I've described as a simplistic version. I'd forgotten I'd even done this actually. We take the literal of the head. So this is an example where we assume there are no substitutions, in which case the head of the literals is the whole thing. And we run our url.parse method. I don't know what that is, but let's say it's implemented. We run that on that thing which I've for some reason written out twice. And we check whether it was no failures, in which case we proceed to return nil as before. If we had a parse error, and this method, my imaginary method, will fail on the first occurrence of an error, and we'll have both a message and an offset within that. And we call context, this is the static interpolation context, .abort. That will stop compilation. Compilation has failed, there's no going back. And we will report back, the way that will manifest itself is the user will see a Scala Compiler error with the message that you have there. And there will be a little caret that points to the position that's determined as an index from the start of the string, determined by offset. You can also warn. If you want to warn, then you can do that. But this will abort. The return type of this is nothing, so we're still returning nil. Now, for a simple interpolated like URL, we need to define some contexts. I've got a context for the scheme in red, for the domain name in yellow, the path in green, and the key in this light blue, and the value to a key in dark blue. What we do is inside our interpolator, we define, first of all, a sealed trait representing the context. And for each context we want to represent, we provide a case object that extends that URL context. It's following a recipe. There's nothing particularly complicated here. And then inside our contextualize method, rather than just returning nil, we are going to return a list of instances of this URL context. So we're going to basically contextualize the holes. For each hole, we're going to say, what is the context in that position? Now, this kind of assumes that there is enough information from the literal parts of the string to work that out. And I mentioned it before, but that is up to you. That is up to you to work out what you can know about those holes to give them context. Your choice of contexts is determined to some degree by what you can actually work out from the fixed literals. But we can return a value here. It'll be something like a list of, and it'll be dynamic obviously, otherwise it's not very interesting, but it'll be something like a list containing the path context and the value context, which refer to this substitution here and this substitution. And we know that escaping, I think for a URL, this escaping is actually identical for the path and the value here, but we could potentially provide different methods there for doing the escaping. And I mentioned we need to actually define what happens at runtime. Once we've passed the contextualize method, once we've got through that without causing any aborts, we now get to the runtime and we have to define this evaluate method, which takes another context, which is a superset of the information we have available at compile time. It's a runtime interpolation. That gives us the literal values again that we had before, but it also gives us access to the parts. Actually, parts for contextual is all of them. We can access both the literals and the other values. We can we're being quite lazy here, and we're just calling toString on them, and then we're making that into a string. But you can do whatever you like to interpret those however you see fit. And there are other methods on runtime interpolation which allow you to determine the context of the whole, so you can interpret things in different ways. And then the return type here can be anything, actually. So I've just used Java net URL. It's a known type. I wouldn't recommend that especially, but we can return that. Now this is sort of related to the point I made to Chris earlier, in that in my definition of how to embed a string, I'm dealing with escaping here. Now this is something I'm not so happy with in the existing version of Contextual, because you can write a type class which allows you to circumvent the safety. This is the type class instance. So this code here, I want to in version 2 will be part of the definition of the interpolator itself, and the definition of this will be a lot simpler. It'll say basically for each of these, just substitute it identically. Now, it's pretty safe to URL encode things in path, key, and value context. But a domain can't contain, for example, a percent sign, which will potentially be involved in a URL encoded version. So there's no canonical way to convert an arbitrary string to a domain name, but all I say is we just replace all of these. What you might, all of these non-alphanumeric, I don't even allow numbers, do I? Any of those characters. What you might like to do is simply forbid substitutions in domain position. That I think would maybe be more reasonable and safer. In which case you just leave off this line and handle only those cases you want to handle. Is that all okay? You might be thinking, well, how the hell is this implemented? That's a different talk, unfortunately.
What is on?
On is it's an object with an apply method. It's like case. But the way this works is these are varargs, and I'm doing some very crafty but non-macro type inference there. I'm very proud that there's no macros involved here, such that it is able to infer an appropriate type for this, such that the contextual interpolator is able to pull in the type class as and when it is required, but otherwise it won't resolve. And you get a nice message to say, if you try to embed a type that shouldn't be there, then you get a message to say that you can't do that. So that is basically what's involved in writing an arbitrary interpolator. There's a couple of little things, little loose ends. I've so far assumed that the type of things you embed will be strings, because you're working with what's fundamentally a string, and shoehorning any type into a string is usually possible. But particularly with Contextual 2, I call it Contextual 2 as if Contextual 1 had already been a massive success, but it's called 2 because it's semantically incompatible with version 1. So it's not a significant change from what you're seeing here. It'll just have some breakage. I'd like to encourage people to use dedicated types for putting things into the holes. Chris, yeah.
That was kind of my question. Is it possible to, instead of just using an arbitrary data type, without any additional type information for your context, to actually use the GAT and then parameterize things according to parameterize the values according to those holes according to the GAT?
Right. So not really. The way it has to work at the moment is that the macro uses runtime reflection at compile time to instantiate those case objects. So it expects them to be at least objects. I don't know if it insists on them being case objects, but they have to at least be objects because it needs to get the actual instance in order to construct at compile time the static interpolation type. So the macro does some really hairy stuff to avoid linkage problems or sort of chicken and egg situations where you're writing code that refers to things that don't exist yet. So it does some stuff there to using runtime reflection, and it goes as far as instantiating case objects. You could potentially extend that to something more complicated, but it's a huge amount of work. Depending on how arbitrarily complicated you go, you might be able to do it, but at the moment, no is the answer. I'm not saying it's not desirable. It might make things a bit nicer, but it's currently a constraint. So yeah, I've assumed that when you're putting things in, those lambdas convert them to those lambdas in the type class instances I showed you convert them into strings. But you could convert them into other types. With the XML example, you might want to distinguish between string-like stuff and structured XML-like stuff. And your type class would safely convert it into one of these, either a string, an unescaped string, should I say, or an XML structure. and then the escaping would be done inside the interpolators. That is what I'm moving towards with the next version. By the way, if this makes no sense, if talking about input types and so on, you're wondering what I'm talking about, it doesn't matter. This is quite a subtle point. I'm just covering it for completeness. I'm not going to tell you the truth, and I've only got 5 minutes. I thought I'd deleted that slide. So just to give you an overview, I've tried to summarize this. Contextual makes it possible to define interpolators for custom types in Scala and provides an extensible API for defining where, when, and how types may be substituted into them. That is one way of looking at it. I also like the sort of opposite view. A library built with Contextual can make it impossible to write or to represent instances of some type which simply should not exist. It makes it impossible for you to bake into your code stuff that is wrong. It makes it impossible for you to put a string in your code which will be run at, which will be evaluated at runtime and guaranteed to fail. So it lifts to the compile time a lot of the checking that would otherwise happen potentially in production. So almost at the end, and done pretty well on time, I think. The latest release is 101, and that is available for 3 different platforms, which have all been tested, and 3 different Scala versions. The website is basically contextual with a dot, 2 characters before the end and 2 characters after the beginning. .al domain names, they exist. The Gitter channel, there's the project on GitHub, and I will also talk about Contextual occasionally on Twitter if you want to follow me. I'm at Propensive. And that is everything. I'm more than happy to take questions either now or in the remainder of the conference. So thank you very much.